We're at gotomath.com, and we've added an additional button, and I'll show you what that is here in just a second. So before, you could click on area here to get the problem set to come up, and you can actually still click on that if you want. But let's say, for example, we select this, we do this problem, we get the answer, but now we want to see the problem set again, so we just click that to get the problem set to come up. Alright, no big deal. Let's get started here with number 1. Okay, always trying to improve. And so what we're going to be doing here is, in this section, we're going to be finding area. And we're going to be given some curve and an interval. Of course, you think of a curve as a wavy line, but in this particular case, it's a straight line. Okay. Now, if we wanted to find the area of this rectangle, we would just take the length times the width, or you could say the height here, however you want to say it, and multiply those two numbers together to get to get the area. However, we're going to use calculus to find area. So you're like, whoa, that sounds kind of we're overreacting there to find the area, but what happens if this line is a wavy line, right? So we can't really do that. And that means things are changing with x, right? With respect to x, it's all changing, right? Y is changing with respect to x. Anyway, so let's demonstrate on how to find the area of this rectangle using calculus. And of course, you know how to do this already. All right, you already know how to do this. So let's just check it out. So we're going for the integral from -6 to 7 dx. Let's bring up the whiteboard. -6 to 7. So -6 to 7 dx. Now, of course, remember there's a 1 right here, even though it's not written. Okay. So we go ahead and find the integral. So you've done this in the definite integral section. So this means that we just add an x here, and we're going from -6 to 7. Alright, so we plug in the upper bound, so that'd be 7 minus the lower bound, which is -6. And you're not going to believe this, but this becomes 7 plus 6. I don't know why you wouldn't believe that, but so it looks like 13. Now, since we're working with area, right, area is usually measured in inches squared or centimeters squared, or let's say feet squared. Right now, I'm not writing the units, okay, but if there's not any units, you'd probably say units squared or something like that, whatever the units are. However, I'm just going to go ahead and leave this part off. Alright, so understand that. But it is area, and it normally has units, and if it does have units, then we put those units squared on the end. But I'm just going to be leaving that off, okay? So it'll be assumed on all these problems that it's units squared. Well, anyway, we get 13. Let's go back and check that out. Where's the answer at? I've added that new button. I'm like, where'd the answer button go? There it goes. So anyway, so 13. So as you can see, it's just boom, right? Now, I guess I should have said something here real quick about this. So this is our f of x, right? And when you graph f of x, of course, the graph of f of x, which is equal to 1, here, that graph is just a horizontal line going straight across. Okay, and of course we had some shaded region, which I'm using green for our shaded region. I don't know why. Let's just pretend it's grass, and you are cutting the lawn. There you go. So that's interesting. We'll be figuring out what the area of somebody's lawn is. How's that? And that's actually important, especially if you wanted to charge them by the square foot. And so you need to figure out how many square feet somebody's yard is. Okay, so we're moving on to the next problem. It's pretty simple stuff. It will get tricky here in a minute. Okay, tricky just a little bit. Alright, so man, I added that new button. It's like, where am I at? So we're here at gotomath.com. Come by, practice that, and I'll see you later.